Tesla Gold here, and I've built this, I guess, rotating field generator, I could call it. It's essentially based on Tesla's rotary field transformer, but it has no output coil at the moment. But essentially what it is uses two phases. You have two sets of coils. This is one set and this is the other set. They're 90 degrees out of phase with each other. They're wrapped around, the iron core is made of baling wire. I looped some baling wire. It's wrapped with what's the gauge, like 16 gauge, I believe it is, 18 maybe. So, but there's a slight difference in the induction. I believe these two coils each have about 16 microhenries induction. These two coils have like 20 microhenries induction. I'm also using a capacitor here that I salvaged from an old motor for generating or helping generate a phase shift. So anyway, let me turn this thing on and give a little demonstration. And it's currently pulling an amp right now. But I'm going to take some, these are some iron filings, and just to show how it almost looks like sand flowing in water. But you can kind of see how the field travels around. It kind of circles around into the middle. But if I keep moving it around, let me stir it up a little. So you can see it's the fields appear to be rotating counterclockwise, or at least what we're seeing here. Okay, next I'm going to take, let's say this is a little piece of wire. Oops. There we go. There's sort of a sweet spot in it. You can actually kind of control if I can lift this up. Let me try this with, I think I had a larger one around here somewhere. Oh. Whatever. Okay, let me try, this is a magnet, or excuse me, a compass needle. It can be controlled, the position the same way. The fact that it's not perfectly in the center tells me there's probably a slight imbalance in the field. The core is kind of crude, and so is the wrapping, so that's kind of to be expected. But let me give another demonstration. Sometimes these things can be hard to catch from the field, though. Oh, here's the other coil. Here's a larger coil. This is the same type of wire I wrapped the core out of. See, it's the bigger iron wire has a slightly slower rotational speed, even though there's actually more magnetic mass for this piece of wire. I'll give this a demonstration. Just notice how this very rapid rotation. even though it's actually less material. So anyway, let's see. Next, I'm going to put a little bearing in here. And then I'm going to take this aluminum disc. Now this aluminum disc contains no magnetic material. But you can see it's going to rotate. By the way, I'm just driving this with 60 Hertz. There's no frequency control on this as of yet. So this is all just strictly 60 Hertz at the moment. So, anyway, let me move this. Now I'm going to put this on here. This is just a plastic bowl. And this is a ball magnet. The field extends quite a ways out of the transformer, and that's the reason for putting the cup here upside down, because the field is actually in some ways stronger up above and below the transformer than actually in the middle. And I have one more big demonstration that I want to do of just how much power this field can establish. Now we saw that the small steel wire spun much faster than the big steel wire, which, you know, might seem pretty logical to most people, I'd say. You know, you could argue, you know, well, there's more steel in one, why isn't it having a greater interaction with the field? And I think that's a pretty good question. But right now I'm going to take this big aluminum dish, I'll put it right here, make sure there's nothing touching or anything. And is it? Let me see this wire here. There we go. Now let me flip this on. Now this is quite a large disc. It's the same amount of power that I've been driving everything else with. But watch the speed this thing will achieve, assuming it can stay stable. Get it a little more in the middle. So this, actually, if you will notice, is spinning much faster than the first aluminum wheel. Even though this wheel is much larger in mass than the aluminum, or the smaller aluminum wheel. And it's picking up quite a velocity. Let me see if I can do a But anyway, I think that's, quite frankly, very interesting. A lot of energy stored in that. So, I'd be interested in hearing people's thoughts on why some things perform better than others. Maybe things of that nature. You know, it seems pretty obvious to me the less amount of the small amounts of iron work better than the large amounts of iron. The large amounts of aluminum work better than the small amounts of aluminum, which is what I get from this. You know, this ring, I guess what you could call this too is a traveling magnetic wave as it travels around the circle. And I think that's a good description, a traveling magnetic wave. I've been doing a lot of reading on Eric Laithwaite lately, and I think he's got some interesting ideas. So anyway, Tesla Cult signing out.